Hello, this is Charlene. We will be solving an absolute value equation in this video. Our equation says that we have the absolute value of 8 minus 2n minus 5n, and that's equal to n plus 2. So the first thing that we want to do is to isolate the absolute value itself. So we need to get just this part all by itself. So let's go ahead and get rid of all that. Okay, so the first thing I want to do is go ahead and move this piece over here. This piece is going to move to the other side. So how do I undo or move to the other side? Minus 5n. Well, I'm going to do a plus 5n on both sides, of course. 5n and plus 5n. Okay, so these two items will cancel each other out, and I'll end up with absolute value of 8 minus 2n is equal to n plus 5n plus 2. And of course, using our order of operations algebra rules, we're going to go ahead and combine these two like terms. So I'll end up with absolute value of 8 minus 2n is equal to 6n plus 2. And that's because I'm sure you remember there's an invisible 1 in front of there. So 1n plus 5n equals 6n plus 2. Okay, so now that we have isolated the absolute value, the only thing on this side is the absolute value. Now we are going to work it out twice. So how we're going to do that, we are going to write 8 minus 2n, just exactly what is inside the absolute value, and that's going to be equal to exactly what's written here, 6n plus 2. But our second version of this is going to be 8 minus 2n, exactly what is inside the absolute value, and that is going to be equal to the negative of 6n plus 2. And of course, the reason why we do this is because it is an absolute value. When we have the absolute value of, say, a negative 7, well, and they have the absolute value of a positive 7, both of those are equal to a positive 7. So the thing is, though, the point being is that whatever's in the absolute value, it can be the negative version or the positive version that is inside there. So we've got the positive version, we've got the negative version. We have to address both of those possibilities when we're dealing with absolute values. Okay, so now at this point, we literally are just going to use our order of operations from algebra to solve these two equations. So I am going to, let's what I do. I'm going to subtract the 6n from both sides. Subtract the 6n. These will cancel out. I'm going to end up with 8 minus 8n, and that's going to be equal to the positive 2. And then I want to go ahead and do minus 8 on both sides. So these are going to cancel out. So I'm going to end up with negative 8n is equal to 2 minus 8, which is negative 6. And then at that point, I can divide out the negative 8 on both sides. Divide out the negative 8 on both sides. Cancel, cancel. So n is going to be equal to a positive. Of course, your negatives are going to cancel out here. So you'll have a positive 6/8. However, that is going to reduce to 3/4. So potentially, that is my first solution for n. So now let's work the other equation out over here. So same thing. The first thing I need to do in terms of order of operations is go ahead and distribute this negative into the parentheses. So I'm going to have 8 minus 2n is equal to negative 6n minus 2. Okay, at that point, let's go ahead and say plus 6n to move that over here with its like term. So plus 6n on both sides. Cancel, cancel. I end up with 8. 6 minus 2 is a plus 4n. Plus 4n. And that's going to be equal to negative 2. Now I'm going to go ahead and move my 8 over to be with the 2 because they are like terms. So minus 8 on both sides. Cancel, cancel. 4n is equal to, the two negatives cancel each other out, and I end up with negative, oh, this is subtraction. See, sometimes I make mistakes. That happens to all of us. Okay, so negative 2 minus 8. Start negative, get more negative. That means I'm going to have even bigger negative, negative 10. Then I can divide out my 4 on both sides. And when I do that, these cancel out and end up with n is equal to a negative, I'm going to go ahead and reduce it, 10/4 reduces to 5/2. Okay, so potentially that is a second solution for my equation. But we have this thing up here that tells us that we have to check for extraneous solutions. We must check for extraneous solutions. Okay, so what that means is that I'm going to use the 3/4 and I'm going to plug it back into my original equation and see if it actually makes a true statement. So let's go ahead and scroll down here. Let me move this down. This is something we're going to look at here in just a few minutes, but not right now. Okay, so my original equation said this. I'm going to plug the 3/4 into it. So let's go ahead and do absolute value of 8 minus 2. The n is potentially equal to 3/4. Absolute value minus 5 times the 3/4 is equal to 3/4 plus 2. Okay, so let's work it out. Just algebra order of operations. So right here I have 8 minus 2 times 3/4. So that's going to be minus 6/4. If I work that down, let's see here. I could do 8 minus 3/2 just to reduce that fraction. But then I'm going to turn 8 into a fraction with a denominator of 2. So I can say 16 divided by 2 is also equal to 8 minus 3/2. And as you know, it's still absolute value all the way down. I haven't actually solved that yet. So 16/2 minus 3/2, that's going to be 13/2, absolute value of that, which is going to be 13/2. The absolute value of 13/2 is 13/2. Okay, but I still have this minus 5 all the way down, minus 5 times the 3/4. Times the 3/4. Okay, so let's go ahead and work that out. 5 times 3/4 would be, 5 times 3 is 15, so 15/4. And if I go ahead and change this up to have the same denominator, I could have 26/4 minus 15/4. 26 minus 15. What is 26 minus 15? Do you have your calculator? Okay, 11/4. 11/4 is what that's equal to. Alrighty then, so now we need to do the other side. I've got the equals over here, equals all this stuff. So what is 3/4 plus 2? Well, 3/4 plus 2 with the denominator of 4 would be 8, right? 8/4 is equal to 2. So then that is equal to 8 plus 3, 8, 9, 10, 11, 11/4, which of course if I bring that all the way down, does 11/4 equal 11/4? Yes, it does. So this is a correct answer. 3/4 is definitely a correct answer. Absolutely. Okay, so now we're going to try the other solution, 5/2, negative 5/2. So again, we're going to take our original equation and we're going to plug in negative 5/2. Now, if you have your graphing calculator and you want to do it with the graphing calculator, be my guest. But for those of you who need a little review on the fractions, we'll just do it the long way. So there's a possibility you might want to fast forward through some of this stuff. Okay, so absolute value of 8 minus 2 times negative 5 halves. Absolute value minus 5 times negative 5 halves is equal to 5 halves plus 2. Why don't we go ahead and use our graphing calculator? That might be helpful. Okay, so graphing calculator, turn that baby on. Okay, so I've got 8 minus 2 times 5 halves. Let's go ahead and use our fraction function here. 5 halves. 5 halves. Get out of that. And what is that extra equal to? So they say it's equal to 3. So absolute value of 3 is going to be equal to 3. But then I have minus 5 times the negative 5 halves. So let's go over here, use our calculator again. I've got 5 times our fraction of 5 halves. Okay, so that's 25 halves. So that's going to be a positive. A negative times a negative is going to give me a positive. So positive 25 halves. And on the other side, I'm going to have 5 halves plus 4 halves, because 4 halves is equal to the 2. And let's go ahead and change that 3 into a fraction with a denominator of 2. So it's 6 halves is what 3 is equal to, plus 25 halves is equal to, over here I can go ahead and add that, 9 halves. And 6 plus 25, that's 31 halves is equal to 9 halves. Is that true? Absolutely not. It is not true. This is not equal to, oops, what's going on here? Not equal. So not true. And so therefore it is not a solution. Not a solution. So therefore it is extraneous. We do not need it. It is an extraneous solution. Extraneous. I sometimes misspell things on these videos, so you'll have to overlook me sometimes. Okay, so the first solution is correct, and the second solution is not correct. So we can also look at the video. That's what I had down here, a picture of the function. It's like if I put my function, and of course I have to kind of move it around. Anytime I want to look at a function, I want to put it in y equals format, or f of x format is equal to everything else. That's the way that I can put it into a graphing calculator. This is from Desmos, and you can see right here that right here 3/4, it's like 3, a different marker here, 3/4, 0 is on the x-axis, so that means that it is a solution, is a solution. We can see that from the graph physically. But when we put this function in there, it actually ends up being more of a line. And there are no negative solutions. So that confirms that this answer cannot be right. Only this one shows up on our graph right there at 3/4 on the x-axis. So anyway, I hope this has helped. That's a little bit lengthy, a lot of moving parts, but if you use your graphing calculator for some of the lower level calculations, and it goes a little bit faster. But hopefully that was helpful. Like the video, subscribe if you like, and hope you come back soon.